Hello, this is Jenna Griffith reporting for ICP News. Today we are going to talk about Newton's 3 laws of motion. But before we get started, we're going to let you know a little bit more about who Newton was. So obviously, Newton was a scientist who was born in 1643 and lived until 1727. For his education, he attended Trinity College in Cambridge and the King's School in Grantham. Newton was never married and had no children, and Newton was very interested in the Bible, which is a little-known fact about him. So we're going to start right away with Newton's first law of motion. It states, an object at rest stays at rest, and an object in motion stays in motion with the same speed and the same direction unless acted upon by an unbalanced force. Now over to Brayden and Jackson to give you a live demonstration.
The coin has inertia, which means it wants to go down. And when you pull the card, gravity will force it down. Now on to Jenna for Newton's second law.
Thanks, Brayden and Jackson, for that wonderful demonstration. Here we go with our second law of motion. The second law of motion states that an acceleration is produced when a force acts on a mass. The greater the mass of the mass being accelerated, the greater the amount of force needed. Now back to Brayden and Jackson for our second demonstration of the day.
Okay, thanks Jenna for describing Newton's second law. Now, for this experiment we're using a truck that weighs 100 newtons and a light bulb that weighs 50 newtons. So once I pull this truck and it's moving at constant velocity, that means the whole thing is moving at 2 meters per second. And since the force, or the weight is the same, that means the force is the same. And that's our experiment. Now back to Jenna for Newton's third law.
Thank you once again for that demonstration, Brayden and Jackson. Now here we go to explain the third law of motion. The third law of motion states, for every action there is an equal and opposite reaction. Now let's go back to Brayden and Jackson one more time for our final demonstration.
Thanks Jenna for the explanation of the third law. Now here's the experiment. I'll be running into Jackson with this ball because Newton's third law that every action there's a reaction. Ready? 1, 2, 3. Stop.
Thank you once again, Brayden and Jackson, for that final demonstration. And thanks to all of you for watching, and please do not try any of these demonstrations at home, especially the last.